So today we're going to talk about dividing polynomials, and how it works is when you divide polynomials, as long as their index is the same, you can just divide the numbers on the inside and then simplify it from there. So let's take a look. So when you're doing dividing, outside you can divide with outside, so that 12 divided by 2 will give you 6. Inside, in this case, because they have the same index, can divide with inside. So 160 divided by 5 gives me 32 on the inside. And then you simplify it from there. So you do the birthday cake from there. So you got 32, which is divisible by 2 to get 16, divisible by 2 to get 8, divisible by 2 to get 4, divisible by 2 to get 2, divisible by 2 to get 1. And just like you did before, the 6 stays on the outside, and it's going to be multiplied to, you have one group of 2's, you have two groups of 2's, and that's it. What's left over is 1, 2, so that stays on the inside, and then you multiply whatever's out there. So 6 times 2 is 12, times 2 is 24, so it's 24 root 2. Same thing with the next one. You do 36 divided by 9 first, so that gives you 4. And then you have the fourth root, and since they have the same, you can just divide them. So 1250 divided by 2 gives you 625. And then you use the birthday cake from there to simplify it down. So 625, 2 does not go into it. 3 does not go into it. 4 does not go into it. So 625 divided by 5 is the only thing. Which gives you 125. Then you can divide by 5 again. Get 25. And then you can divide by 5 again to get 5. And then you can divide by 5 again to get 1. Again, the 4 stays on the outside. You're looking for groups of 5. And everything comes out. So you got one group of 5 that comes out. They get multiplied together. So my final answer would be 20. For letters, you can do the same thing, but when you do it, you got to subtract their exponent. So 3 minus 2 gives you 1x. 9 minus 5 gives you 4y's. And then same thing, okay, for the x's, you do it each one. So the index again is 2 if you don't see it. 2 goes into 1 0 times with the remainder of 1. So that means that x is going to stay on the inside. And then for the y, 2 goes into 4 twice with the remainder of 0, which means that 2 y's will come out, nothing stays in, and there's your final answer. It even works when you have all things working together. So 28 divided by 4, if you do that, gives you 7 cube root. Negative 16 divided by 2 gives you negative 8. M to the 6 divided by m gives you m to the 5th because you subtract their exponents. And then you can simplify it from there. So let's do the 8. So when you do the birthday cake of 8, we're looking for groups of 3. So all of those, so that means negative 2 comes out. And then you do the same thing for the letter. Okay, so 3 goes into 5 once with the remainder of 2. So that means that 1m comes out, 2m stay in. So my final answer would be negative 14 m cube root of m squared. Okay. But that's all if they all divide nice and evenly. Sometimes they don't. And if they don't, you have to do this thing called rationalizing the denominator. Here's how it works. Whatever the index is, that tells you how many of that thing you need. So if the index is 3, that means I need 3 A's. If the index is 5, I need 5 A's, and so on and so forth. Okay? In this case, the index is 2, so that means I need 2 5's. So what I'm going to do is I'm going to multiply by the square root of 5, because now I have 1, 2 5's that adds up to the index of 2. When you do that, what happens is these two things go side by side, so you get 3 square root 5. On the bottom, what happens, this 2 stays out here, and what happens to, and it's going to get multiplied, what happens to the radical when you do square root of 5 times the square root of 5, it just drops that radical and makes it 5. So my final answer would be 3 square root 5 over 10. And then you got to double check to make sure that these two numbers don't reduce. In this case, they don't. So that's my final answer. Same thing with this one. Square root of 8 over square root of 15. Now this means with the index, that means I need two 15s. So I got to multiply by the square root of 15 over the square root of 15. When you do that, you're going to get the square root on the top. 8 times 15 gives you 120. On the bottom, square root of 15 times the square root of 15 is just 15. And then you simplify what you can from there. So we have 120. So when we divide that by 2, that gives me 60. Divide that by 2 again, that gives me 30. Divide that by 2 again, gives me 15. You got 3, which gives you 5, and 5, which gives you 1. You're looking for groups of 2. So they have one group of 2 out there. So that 2 is going to come out. And what's left inside is 2 times 3 is 6, 30 over 15. And you only look at the outsides, they don't reduce, so that you're done. So the same thing for the next one. We would multiply by the square root of 7 over the square root of 7. So that'll give me 3 square root of 12 times 7. Give me 84. On the bottom, you get 4 times 7, because the square root of 7 times the square root of 7 is just 7. We're going to reduce 84 by dividing it by 2 to get 42. And we're going to divide that by 2 to get 21. And that gives, divide that by 3 to give you 7, 7, and 1. Okay, so you got a group of 2 there. So this is going to be 3 times now 2. Square root of what's left, which is 3 times 7, so 21, over 28, which is 6 root 21 over 28. But if you look at the outside numbers, they're both divisible by 2, so that means that it's going to be 3 square root of 21 over 14. And same thing on the bottom. So it's the square times the square root of 3a over the square root of 3a, because I need 2 of everything because the index is 2. So 3 times 28 is 84. The square root of 84. A to the 6th over 3a. So when I simplify 84, I get 42. When I divide that by 2, I get 21. When I divide that by 3, I get 7. Divide by that by 3, I get 7. I get 1. So this is going to come out as 2 square root of 20. 2 square root 21, but then you got to also deal with the a. So 6, 3 goes into, or 2 goes into 6 3 times with a remainder of 0, which means all 3 a's come out. Remember, it's over 3a. And you can simplify the a's to get 2a squared, square root of 21 over 3. All right. It does slightly change when you do the conjugate. Okay, when you have more than one thing down there. What you have to do with these is you have to multiply by the conjugate, which is the negative version of that denominator. Okay, and you do that to both the top and bottom. And what you have to do from there is you have to go ahead and multiply that 4 to the 16 and the 4 to the square root of 2, which is just 4 square root of 2. On the denominator, here's what happens. The 4 will get multiplied to the 4 to give you 16. The 4 will get multiplied to the square root of 2, which gives you negative 4 square root of 2. But you also have to do it with the square root of 2. So you get positive 4 square root of 2. And then when you multiply the square root of 2 times the square root of 2, you get just 2. And then what happens is these go ahead and cancel out in the middle. It should always happen that way. So then you get 16 minus 4 square root of 2 over 14 because you got 16 minus 2. And then you just lastly have to check, can I reduce these numbers? Is there a number that goes in all three? And in this case there is, it's 2. So you do 8 minus 2 square root 2 over 7. That's your final answer. Same thing for the next one. We're going to multiply by 6 plus the square root of 5 on both the top and bottom. Okay, so that distributes. You get 12 plus 2 square root 5 over, again, that gives you 36. That gives you positive 6 square root 5. Then you do the square root of 5. That gives you negative 6 square root 5. And then that gives you negative 5. And again, as I told you, these middles should always go away. And you should be able to combine these two. So I get 12 plus 2 square root 5 over 31. Double check the outside numbers, 12, 2, and 31. There's nothing that goes into them, so that's my final answer. Okay, and then we're going to not do these two on the bottom. That should be enough information for you to do these problems.